Good morning, everyone. Today I will introduce my paper, Study of the Propagation Direction of the Internal Webs in the South China Sea using Satellite Images. Internal webs propagation usually carry considerable vertical shear, so it leads to seawater turbulence and mixing. At the same time, pause risk to vessel navigation and is also harmful to oil platform. It disrupts sound wave transmission too, so it will pose risk on military operations. Let's move to the generation of internal webs. Please look at the figure below. This is the topography of 21 degrees north near South China Sea. Here is Taiwan and here is Luzon Strait, and here is Pacific Ocean. Internal tide form as barotropic tide at Pacific Ocean and interact with topography of Luzon Strait, these two sea mountains. And when it propagate westward, topography will steepen and that the internal tide become nonlinear. After becoming high-frequency internal solarity wave packets, when it keep moving to the continental shelf, it will be shallowing and dissipate in the continental shelf. This is the whole life cycle of internal webs. Our goal of this research is to understand the path and propagation direction of internal webs. That will help us to know their impact on ocean dynamics and ensure the safety of large artificial structures. Here are our data resources. From 2005 to 2010, we use ERS2, satellite SAR, images, and Inmarsat satellite ASAR, both of them from European Space Agency, provide 75 meter and 12.5 meter pixel spacing satellite images. The third one is Terra and Aqua satellite from MODIS project of NASA. It also provides different resolution images. The last one is Huanjin satellite belongs to China National Space Administration. Please look at the figure at the left-hand side. This is the topography of South China Sea. Each little red line here represents an internal wave packet we have identified from the satellite images. Because of the topography and the distribution of internal webs, we divide South China Sea into 5 regions: Northwest South China Sea, Northeast, Northwest, and Western, Eastern, and Southern South China Sea. Because there is no internal web has been observed in the Eastern South China Sea, so we only analyze the other 4 regions. First, let's move to the Northeastern South China Sea. Because of the topography and the distribution of internal webs, we divide this region into 2 areas, east and the west area of Dongsa Island. In the east area, internal wave propagate direction is between 220 degree to 330 degree, and the field propagation direction is between 50 degree to 150 degree. At this picture, this white dot is the position of Dongsa Island, and the small arrow here, many small arrows represent the internal wave propagation direction and its path from the satellite images. And a big white arrow like this is the several internal wave propagation direction and its path. The west area of Dongsha internal wave propagation direction is between 210 degree to 360 degree. In short, internal wave in northeastern South China Sea propagate westward from the Luzon Strait, and some reflect near Dongsha Island, and some internal wave impinge onto the shelf. This white point is Dongsha Island. And at the northwestern South China Sea, internal wave propagation direction is between 260 degree to 360 degree. This area is near Hainan Island and Beibu Gulf. It's in the south of China. And at this area, internal wave propagate westward or northwestward to the coast and the Beibu Gulf. And some of internal wave will reflect by the topography. In the western South China Sea, it is near the south of Vietnam. And we also divide it into two areas, north and south sea area of 13 degree north. Internal wave in this area propagation direction is between 210 degree to 300 degree. And in the south area, internal wave propagation direction is between 220 to 320 degree. It's only a few samples at this area. In short, internal wave in western South China Sea propagate to westward to Vietnam coast, and just a few propagate to the southward like this, to the deep sea. Deeper sea in this picture is deeper blue. The last area of South China Sea is southern South China Sea. Internal wave in this region propagation direction is between 260 degree to 360 degree. And the most internal wave propagates in this region to the southwestward to coast, and some will propagate southeastern to the Kalimantan Island. Kalimantan Island is here. And just a few near Vietnam coast propagates southeastward. So, as I mentioned above, you can see in the picture, about 60% of internal wave we have identified occur in the northeastern South China Sea, near Dongsha and the South China. And a few are near the Vietnam coast, like this, and Hainan Island. And no internal wave in the eastern South China Sea. In conclusion, most internal wave propagate toward the coast, and just a few are reflected by the topographic features, like Dongsha Island and the coast near China. Thank you for your listening.
Thank you for your good presentation. And one wonder that what does the international wave act in the transport of the sediment in the northeastern South China Sea, also called the Taiwan Bank, 台湾银行没有了。It's called Taiwan Shoal, 台湾浅滩。Because in our toll sample, we saw the basic foraminifera 底栖性有孔虫 see in the surface water. Do you know what does the international wave act in the transport of the sediment? Internal wave and sediment transport. Yes.
You means this area? Because I have read this paper, and it's data tell us that when internal wave move through this area, it will be shallowing and it will be broken into several turbines. So it may cause the sediment to
To the surface ocean. Yes.
yes.
Okay.
Because this area is very not
Very
deep.
sh-
It's
yes,
not deep.
very shallow.
Yeah.
Very
So
shallow. Yes.
is that your question?
Yes. Thank you.
Thank you.
I want to ask, you just said the internal wave is highly related to the topography, is that?
Yeah.
I want to ask, the topography is only on the water or below the water? I mean, only affected by the big island like continent or something, or the underwater like shelf or something?
When it meet the topography, like the continental shore, like this area, near Dongsha, you can see this area with deep blue and light blue. It's between this area, the internal wave meet the topography be not deep enough. It will be shallowing and finally dissipate in this area. Internal wave will turn to the turbines. So in this area, internal wave will break, and also in this area, like the offshore near South China, it also break the internal wave into turbines.
And some of them will be reflected, is that?
Yeah, some of them with strong energy will be reflected.
Can you explain the page 8, what red line? Yes, the left picture red line.
Red line represent the internal wave package, because internal wave didn't just a wave. It will a big wave and carry a lot of small wave. So we only can identify the big wave of them, and the small wave will it's difficult to see on the satellite images. So we use the satellite images to recognize the big wave of them and mark it in the every small this red line. Yes.
Oh, so is it just on the surface?
I will say that it's a signal of internal wave packet, but we can't really sure if it contain how many internal wave or yes, I can sure it is how many internal wave in the packet. Yes.
Okay, thank you.
So your data is from satellites, right?
Yeah.
So how as he mentioned, the internal wave is not on the surface. So how do they define the internal wave from satellites?
Because when internal wave light pass through an sea area, it will cause the sea surface become like a this is a sea area, and when the internal wave pass through this way, it will cause the wave like this in the surface, so we can recognize it. But in detail, how them to identify all the internal waves, I just see the like this one is the satellite images. You can see in the surface like this line. So they recognize the imaging, but in detail how they identify, I don't know, and it didn't mention in the paper. Yeah.
I think this talk was nicely done. So I guess, so first thing is this paper is easy enough. That's very important. That's usually a key component of a good talk. Okay, and then here she has this. Her talk speed was. Can you stand here a little bit? Yes, good. You need to be. Yeah. So her talk speed was also appropriate, so you can follow her without any problem. And at the beginning, she has these informative headers. So you here, like instead of using boring, like an internal wave, here she said, okay, this is the importance. So it's a keywords. You always need to tell people what is the importance of your study. So that's very important. And here she found these cartoon from another paper. I think it's a famous paper, I guess. So this is also nice. And however, the thing here is there are so many terms here, like a barotropic tides and solitary waves, dissipation. I really wonder whether you can find your own words to make it easier, okay? Or like a solitary wave packets, or you can just say solitary wave. You can easily draw a curve and say, okay, this is what we call solitary wave. However, what was missing in this talk or in the introduction is you think about the question of Bill and Zixun. So they were asking something related to interaction with topography. And in this way, it would be great that you should show maybe some, I think on the internet, there are many information regarding how you can identify internal wave in CTD-CAST. In this way, you can tell us how deep is internal wave. And that's the reason why it will interact with some submarine topography. So please tell us something about the depth range of internal wave. And then I think the goal, this is really clear, so it's nice. And it's also nice that she added this logo, so this one won't be so boring. And in her results slide, she always makes sure, so that's really my standard. Like you make sure your map is as large as possible. That's very important. This is really nice. And during her talk, at a later stage, she was looking at you, which is also nice. And then, however, before you enter your results slide, what was missing is this one. So you should put this one into your formal talk and tell the audience. Then I think that was also correspond to Stephanie's question that how do they identify internal wave? I think this is so important that you shouldn't put it in the backup and you have time. So use this one to explain how they turn satellite image into this kind of tracks. And then it will be clearer to them. And then again, so these are all very nicely. I'm glad that you add this, so we don't need to think, oh, what is this direction? Okay. And then I think at some point you need to explain like terms like this, like impinge. So you need to be sensitive. And there was a map where I don't know where you are really talking at. There was a map, 16. So I don't know where is this place. So, is it rotated? Yeah. So you need to tell us, like you put a north in this direction. I was thinking, where is Vietnam in this map? So that was confusing. Okay. And you can see that because her talk has a lot of spatial information, 空间的, spatial information. And to help to orient the audience, she always adds this guide map to show, okay, this is the place I'm talking at, etc., etc. So this also makes her talk very easy to follow. So we know exactly where you are talking about. And then at the end, we know, okay, how you reach your conclusion. So that's very important. So I think it's a very good talk. So, but still you can add something to improve the clarity. So hope to see this improvement next time. Okay, thank you, Ariel.